Hi everyone, welcome to this recorded lesson on naming compounds. Now, much like with formula writing, when you're naming a compound, you first want to figure out if it's ionic or covalent. There's a few easy ways to do this. There's no rule of thumb, by the way. There are things to do this, but there's a few tips you can use. So the easiest way to do this is probably to look for if it has a metal in its structure, if the compound has a metal, or if it has the ammonium ion in its structure. If it has a metal, then it is probably ionic. If it does not have a metal, or if it doesn't have ammonium, then it's probably covalent. So we're going to start off with ionic compounds, and all four of these examples are ionic compounds. You can kind of tell because they have a metal. They've got sodium, calcium, aluminium, and again sodium, respectively. The way we name them is quite straightforward. Ionic is actually really easy to name. You just name the metal and the non-metal, changing the non-metal's name to "ide." So in the first case, for example, you'll have sodium chloride. Sodium chloride. So the chlorine becomes an ide. The second element, the non-metal in this case, normally it becomes an ide. Try doing the other three, and I'll pop the answers up in a second. So I did number 2 and 3 here, and all of them are ending in the same way: calcium chloride, aluminium chloride. You'll notice that despite the fact that we have 2 or 3 chlorines respectively in those, we don't actually account for that in the name. We just call it chloride. And the reason for that is there's only really one way for sodium and chloride to come together. Same for calcium and aluminium. When they come together with chloride, it'll always be in this ratio because the charges have to be balanced out. So when it comes to ionic compounds, we don't have to indicate quantity, just indicate what we have in there and change the second element to an ide. In the same way, that last example there, sodium oxide. Things get slightly complicated when you have a polyatomic ion, but not much more. All you've got to do is, if you've got a polyatomic ion like nitrate, NO3, sulfate, SO4, just look up their names in the valency table and use that. So for example, example number 1 is sodium. And the second bit, this part over here, is nitrate. That's what it is in the valency table. So we call it sodium nitrate. Normally when things have oxygen in it, it ends with the word ate or ite. Polyatomic ions like nitrate, they have oxygen in them, and that's where that ATE name came from. They ate some oxygens. In the same way, K2SO4 is potassium sulfate. K2SO3, on the other hand, is potassium sulfite. Normally the lesser oxygen version, so SO4 has 4 oxygens, SO3 has 1 less. If you have that kind of a duality, the one with the lesser oxygens gets the word ite, and the one with more oxygen gets ate. Either way though, ate and ite both mean you normally have oxygens in the structure. You don't have to memorize these. You can always use your valency table and use them to work this out. Our final example has 2 polyatomic ions. The first is ammonium, and the second is carbonate. Again, just read the names directly from the valency table. Another layer of complication you have is when you have transition metals. So you have to be careful when naming metals. Sometimes you've got to look out for whether they're transition metals or not. Easy way to do it, just always look at your valency table just to make sure that they are or aren't transition metals. Iron, lead, chromium, and copper, for example, are all transition metals. They all have multiple valencies. So we have to indicate what their valency is in their name. FeO would, if we name it just the way it is, it's iron oxide. But the name doesn't tell us which version, which valency of iron we've got, right? So we have to work that out and indicate that in the name. The way we work that out is we sort of reverse engineer the formula. We look at what its valencies are in comparison to what we already know. We know that oxygen is 2-, right? and if oxygen's 2 minus, iron, in this case, because it's a 1-to-1 in this formula, it has to be 2 plus. So this is the 2 plus version of iron we've got there. So we call it iron 2 oxide. In the same way, the second example is lead fluoride. But we also need to indicate which version of lead, which valency of lead we've got. Fluorine is normally -1, and if there's 4 lots of it and only one of the lead has got to be 4 plus. So this makes it lead 4 fluoride. Then we have chromium oxide. This one's a little bit harder. When you do formulas, you do the whole swap and drop thing. Here you can unswap and undrop, I guess, if that's the thing. You can take the 3 and move it back up there. Take the 2 and move it back up there. And that'll give you chromium 3 oxide. Finally, we get copper and phosphate coming together. So you've got copper, phosphate. And in this case, the copper is 2. So copper 2 phosphate. Sorry, I'll write that properly. There you go. Copper 2 phosphate. Naming covalent compounds gets a little bit more complicated, not by much, just a little bit. And in that, the reason for this is because covalent compounds, you can actually have the elements coming together in multiple ways. The best example of this is carbon dioxide, and also, we'll put it down the bottom here, carbon monoxide. You can have them coming together. You can have these elements coming together and bonding in different ways, and because of that, we have to indicate which version we've got, what combination we've actually got in the structure. And to do that, we normally use prefixes. So for example, carbon and oxygen together gives you carbon dioxide. So in this case, we actually do indicate what quantity of each one we have in the molecule. So in this case, dioxide means you've got 2 oxygens. Again, notice the second element becomes an ide. So it's not dioxygen, it's dioxide. Next thing, we have PF3. Sorry, that's a really bad 3. That's an even worse 3. That's slightly better. There we go. PF3 is phosphorus trifluoride. And that's tri for 3 fluorines, right? N2O4 is dinitrogen tetroxide. 2 nitrogens, 4 oxygens. H2S is dihydrogen sulfide. Sulfur can be spelled with an F or a PH, depends on whether you're in America or England. We accept both here in Australia. Now, notice here that I didn't say dihydrogen monosulfide. I can also choose to omit it. Normally, the mono is, for the second element, sometimes you indicate mono when it's only one, or you can also choose not to. There's no real convention. The convention is normally to indicate it, so it's probably better if I said mono here, but you can get away with not doing it. Normally, if there's only one of something, you don't say mono. Mono means one, and you can kind of get away with not saying it. However, in question 5, we normally say carbon monoxide. The reason we say mono in this case is we kind of want to differentiate between carbon monoxide and carbon dioxide. So just calling it carbon oxide doesn't really cut it. There's 2 carbon oxides, right? You can have the dioxide or the monoxide version. So we specify mono there when we want to be a little bit specific. So sometimes mono shows up, sometimes it doesn't. If you want to be safe, put it in there anyway. But we normally only say mono if it's the second element. First element, if it's by itself, you never say mono. You didn't see mono here, here, or here for that matter. So it's only the second element that sometimes gets a mono. So to finish things off, for covalent compounds, here are your prefixes. This is what you use when you're indicating quantity, mono, di, tri, tetra, so on and so forth. Again, to point out, when you've got tetra onwards, the A, sometimes you say tetra, sometimes you say tetr and get rid of the A. There's no real convention, but normally that getting rid of the A happens when you've got two vowels together. So dinitrogen tetroxide, you get rid of the A because it just sounds weird to have two vowels together sometimes. But there's no convention to that. There's no rule to that. If you want to be safe, just write the A in. All right, there you go. Thank you for listening. Please do as much practice as you can and ask your teachers if you need help. Bye.